Hello, and welcome to the demonstration of IBM Data Power Operations Dashboard, or DPOD for short. The following demonstration will walk you through the scenario of troubleshooting a service latency problem, which after investigation turns out to be a backend issue triggered by a service configuration change. The scenario will also include defining an appropriate alert as part of a proactive approach towards latency issues. Service latencies and SLA fulfillment are some of the most common concerns that data power administrators face. As you'll see, DPOD is very effective at troubleshooting such issues. But first, let's have a quick overview of the DPOD console. For this scenario, let's say that you're a data power administrator, and you've received a complaint that the performance of a particular service is too slow. The service worked perfectly for a long time, but suddenly its response times increased significantly, exceeding the desired SLA. For exactly such cases, DPOD provides a service latency dashboard, which appears under the Analytics submenu. The service latency dashboard is used to investigate service latencies across all monitored devices. This dashboard can be used to focus on various types of latency problems in order to investigate them. We know that problematic service is on the Bank B domain, so let's focus on this domain. We can now see the list of the top 10 services with the highest latency in this domain. Right away we can see that the service called makeappointment_WSS has the highest latency in this domain. We can see by the graph that until recently this service responded quickly to requests. But then something changed, increasing its response times to around 2 seconds. In order to get more information on this service, we can click its name at the bottom of the chart. The service latency dashboard is divided into several charts. Each chart displays a different aspect of service performance. As we scroll down, we can see that in the request processing graph, request latencies are under 40 milliseconds. We can see in the graph below that response processing times are even faster. However, under backend processing, we can see very slow response times, up to 2 seconds. And so, we can conclude that the backend is most probably the source of the problem, and it is unlikely that the data power processing policy is to blame. DPOD provides not only graphs and statistical data, but also detailed information, allowing you to drill down into each transaction processed by monitored devices. In order to investigate the problem further, we will go to the Investigate section of the DPOD console. Here we can see all the processed transactions for the selected service and time range. For each transaction, we can see when it was executed, how long it took, the name of the device, etc. Let's now drill down to one of the transactions and see what we come up with. This is DPOD's transaction view. On the top left, we can see some general information about the transaction: execution time, device name, operation, and so on. At the top right, we can see additional analysis information provided by DPOD's analytical processes. This is a very comprehensive analysis of the transaction, using all the information collected by DPOD. Under error analysis, we can see errors, if any have occurred. In this case, the transaction was successful, albeit being very slow, so this field will be more useful for cases of transaction failure. Under elapsed time, we can see a diagram which provides a breakdown of the transaction step by step. We can see that out of 2005 milliseconds, 2002 were spent calling the backend. Under memory analysis to the right, we can see details on how much memory was used by data power during this transaction. At the bottom part of the screen, we have a lot more information. We can see the Raw Messages tab, which lists all the raw log messages collected by DPOD for this transaction. This data is more useful for data power administrators and experts. In the Payload tab, we can see the message payload we've recorded. In this case, no message payloads were recorded. Under extended latency, we can see a list of all the processing actions executed by this transaction, and how long each of them took. Finally, under side calls, we can see the service's side calls, if these were made by the processing policy. At this point, although we've identified the source of the latency issue, we still need to explain why the service's latency suddenly changed. Usually, there are two possible causes. Either the backend server is suddenly having performance issues, or something has changed in the service configuration within Data Power Gateway. And so, to investigate this problem further, we will go to the Explore section of the dpod console. In addition to collecting transactional information sent by Data Power, dpod also periodically samples and stores all service configuration information from its monitored devices. This information is displayed in the service configuration page and allows us to quickly search and find information about deployed services. Let's drill down into problematic service and see what sort of information is provided. At the top, we can see basic service configuration data: the service type, which device it's deployed on, the admin state of the service and the front-end handler, IP addresses, etc. Below, under Change Audit, we can see dpod's change tracking log for this service. Each time dpod samples the configuration of a monitored service, it compares it to the previous configuration, sampled for the same service. If something has changed, dpod records it under its change audit list. So if a Data Power administrator changes something in any service, it will be recorded here. Indeed, as we can see, the remote backend port and URI for this service have recently been changed, at the same time when the latency problem began occurring. And so, we can conclude that the cause for the problem is that someone had switched to a different remote backend, which is apparently much slower than the previous backend. Great! We've found a problem, but now we would like to be more proactive. We want to be notified if anything like this should happen in the future. So let's open the Service URI Calls dashboard under the Analytics submenu. In this dashboard, we can see a list of all the URIs and services which were invoked within the filtered timeframe, as well as some important information about latencies: average, minimum, and maximum latencies, number of calls, etc. Let's focus on our problematic service, the Make Appointments service. If we hover with the mouse over each latency statistics, dpod will open a tooltip menu which allows us to create a new alert for this service. Alerts are a very useful feature, allowing the administrator to configure a dpod to send alerts when certain conditions are fulfilled. These alerts can be sent to a remote syslog server or to an email list. When creating a service latency alert, we can configure a dpod to send an alert when a given number of transactions within a given time frame have exceeded a maximum latency threshold. In this case, we can define that if within 10 minutes or less, more than 10 transactions have a latency of more than 854 milliseconds, dpod will send out an alert. And so next time a similar problem occurs, we will be notified instead of relying on the end user to send a complaint. dpod comes with a predefined set of built-in alerts, which you can customize. You can also create new alerts, as we just did. This concludes our demonstration of troubleshooting a service latency issue. We tracked down the problematic service right away, seeing that the problem was due to the backend call. We then found that the reason for that problem was a recent configuration change made to the backend endpoint. Lastly, we defined an alert which will send us a notification when the service experiences latencies again. Thank you for joining us. We hope you find this demonstration useful. You're welcome to see other troubleshooting scenarios in our other videos.